The second example here in the book is the even power of a sine or cosine. I would like you to, I certainly will give you the room to read how the book handles this scenario. Let's try a very similar one, which is on the note. So in this case, the book is again sine x to the power 4, which is an even power. I would like you to quickly review here. So sine even power, when this is power 2, it can be reduced down to power 1 in terms of cosine. And similarly, cosine square can be reduced down to the cosine in terms of cosine as well. The difference between these two formulas is, I hope that you can see that the signs are different. That's it. So now let's go back to this problem and let's give a try. So this is the problem that we are gonna do, right? So here I actually have a definite integral. The book has a indefinite integral right here, but they should be, I hope that would not distract you too much. Let's look at this one. So first I'm gonna treat the cosine to the power cosine x to the power 4 as cosine x squared and then square. All right, and then after that, the cosine x squared, you don't want to use 1 minus sine x squared, okay? You don't do that because they are the same power here. They're the same power. So the that would not help. That would not help. Therefore, I'm gonna apply the half angle formula. If you can remember that, it will be plus cosine 2x. You just, this angle, the original one is half of this angle, and then over 2, and then there's a square here. Okay, so now, and then you continue to square it. By the way, this 2 is just a constant. I'm gonna bring it out. With the square, it becomes 1/4. And then here, for this inside part, like 1 plus cosine, like this part, I'll use the binomial formula. So it will be 1 plus 2 cosine 2x plus cosine 2x squared dx. When we write math, we gotta be careful. Using a grouping symbol is always important. So now, let me continue to write one more step. Actually, you probably can see now this can be integrated directly and this can be integrated directly. Only this piece is still an issue. So I'll wait until next step to integrate it. I'm gonna continue here. So this becomes, apply the same formula one more time. 1 plus cosine of twice of this angle, right? Twice of this angle. So it becomes 4x. So here becomes 4x. Okay, dx. Now, actually, you can see that you can integrate term by term now. So I'm gonna move that over here. So I'm gonna continue here. 1/4, 0 to 2. You can actually simplify it a little bit if you want to. I'm splitting that into the very last term into 2 terms, dx. And what I mean is you can actually combine these 2 constants if you want to, and you really cannot simplify it any further. So now I'm gonna continue to 1 and 1/2 is 3/2, right? 3/2 x, its antiderivative is 3/2 x, and plus the antiderivative of 2 cosine 2x is 2 times 1/2 of sine 2x, which is just sine of 2x. Okay, sine of 2x. And now this 1/2 is already combined with 1, so I don't need to integrate it again. So this will be 1/2 times 1/4 of sine 4x. Okay, and then it evaluates from 0 to 2. So it's just down to the algebra now. So it will be 1/4. Plug in 2, you have 3/2 times 2. Plug in, I'm sorry, it's not 2. But this can be easily corrected, right? The original one is pi. So pi, I'm sorry about that. So this is pi, and this actually is pi. This actually is pi. So this, when we plug in, this actually is pi. So here we have sine of 2 pi, which is actually 0, plus this is 1/8 sine of 4 pi, which is, again, sine of 4 pi is also 0, and then minus. So this whole thing minus. Now you plug in 0. When you plug in 0, everything's 0. 3/2 times 0 is 0. Sine 0 is 0. Sine 4 times 0, which is sine 0, is 0. So this actually turns out to be nice. 3/8 pi. Right? So this is the example for the problem number 2.